Okay, let's try this approach because YouTube does not like publishing links to other sites. So, in order to communicate how the refractive index of air can change, I would suggest you go to this emtoolbox.nist.gov/wavelength /sidor.asp, and you can start to realize all the different factors that can contribute to a different index of refraction. It's the index of refraction that Snell's law requires, or the difference between the two in calculating refraction. So you can take a look at your wavelength. This is the wavelength of the light. This is 633 is within the visible light spectrum. You want to stay within that for anything that you're trying to visually represent as far as what you can see. But you will notice that you can change the air temperature, the atmospheric pressure, the air humidity, and carbon dioxide content. And after doing so, you can take all these values as they exist, and you can ask for a calculation, and that calculation is going to give you the refractive index of the air for all of these parameters. And if you go back, you can write this down on a sheet of paper. You can go back and within the parameters, and you can change from Celsius to Fahrenheit, different means of measure, something that you're familiar with, but you can change the values within the limits that they allow you to change. If you stay within the limits, you can recalculate the refractive index of the air from these parameters, and you will notice that there will be a change in the refractive index of air. So to say air only refracts a certain way in air is incorrect. You can have two different air masses, like an air mass that generates off the warm side of a mountain, adjacent to an air mass that is not radiating off the side of the mountain, and you will get a medium change that will bend light. Okay? And this can be different than the change that is off the other mountain. Or it can be different than the change of what comes from a mountain crosses over a tree that's closer. All of these changes in the medium will facilitate a very small bend in light, and it has nothing to do with radiuses. Snell's law is about angles. The calculation is about angles based on the index of refraction. Learn a little bit about this.